Okay, so in this part of the video, as we continue section 3.4, they're going to give us some different aspects, and we kind of still do the same thing, using our set builder notation or interval notation to indicate when certain things are occurring. So on 29 in part A, it wants us to say, when is the equation equal to 0? So that's just saying, what are my x-intercepts? When am I crossing the x-axis? So as we look at it, it appears something about right here and something right about there. So we're looking at about x is equal to maybe approximately -1/2, and x is approximately -2/2, -2.5. Now, if we really want to find out more precisely where that's going to be, then what we would do is we'd use the quadratic formula. And then we can go through those and find them a little bit more exact there. So we can always go through and take our equation down here and say, all right, -6 plus or minus square root of 6 squared minus 4 times 2 times 5/2, all over 2 times 2. And that gives us -6 plus or minus square root of 36. The 2's cancel. That'd be -20. And that's all over 4. X is approximately -6 plus or minus, that would be 16. Square root of 16. All over 4. So that's -6 plus or minus 4 over 4. So -6 plus 4 over 4, and then -6 minus 4 over 4. So that's -2/4, which is -1/2. And then on the other one, that'd be -10 over 4, which would be -2.5. So even just my eyeballing, I got it close enough there. So now they say let's see, writing set builder notation to write solution sets to the inequality. So we only have to do on the inequalities, which is part B and C. We got to use our notation there. So we did get our x-intercepts correct, and so now we're going to do part B and part C. Part B again is asking, when is the graph below the x-axis? Well, the graph is below the x-axis in that section right there. So for 29B, we would say that between -2.5 and -0.5, that is when I am below the x-axis. For part C, when is the graph above the x-axis? Well, that would be this area and that area. So we would start from -∞ to -2.5. Union, skip over where it's negative, and then we pick up back at -0.5 and go to infinity. And so that would be part C. Number 30, you're going to be doing the same thing. A little harder to see. That one would probably have to use the quadratic formula to do that one. Actually, it looks like it factors. It looks like that factors there. So I'm going to factor it. So to find 30A, we would go through and say, all right, when is this equation equal to 0? That factors, again, if you have a graphing calculator, you can graph it and then see where the zeros by using a feature in the calculator. This would be a 3x and an x. It would be a +2 and it'd be a -2. So using the ZPP, we find out 3x minus 2 equals 0 and x plus 2 equals 0. So when x equals 2/3 and x equals -2. So those are my two x-intercepts. So that's part A. Part B, we get to say, okay, when is it negative? Well, it's negative between the two x-intercepts, so between -2 and 2/3. And part C, when is it positive? That's when it's out here. And so we would say negative infinity to negative 2, union with 2/3 to infinity. So, all right, let's skip down here. Now they're giving us another format to do kind of the same type of stuff, but instead of saying, what are my x-intercepts, they want me to figure out table of values, figure out these inequality things. So again, part A, when are my y answers, because that's what it's saying, when are f of x is my y answers. So f of x are the y answers of the ordered pairs. When are my y-intercepts bigger than 0? So when are they positive? That's part A. Part B is the opposite. When are the y values negative or equal to 0? So this one is negative or equal to 0. All right, so let's do the part A part. When are my y values positive? Well, there's a positive 3. 0 is not positive, so somewhere between negative 2 to negative 1, it stops being positive. And then on the other side of here, we pick up being positive again somewhere right about there, right on the other side of 1. So when are they positive for the part A part? We would say, well, for the x values from negative infinity all the way up to basically negative 1. We know negative 1 is 0, so we would say all the way up to negative 1, it is positive. And then union, we start back again on the other side of this. This is an x-intercept as well. We would say from 1 to infinity, it's positive again over there. When is it negative? Well, it happens to be negative, and it's also, we could say, or equal to. So this is where we get to say negative 1 to 1. That's when I'm negative in between and also equal to 0. So, all right, let's take a look at the next one. Again, same thing. When is it positive? Well, I look for the x-intercepts. Okay, so I see my x-intercepts right there. And so I see to the left here, I'm negative. In the middle here, that's a positive number. And then over here, I'm negative again. All right, so for A, I am only positive in this middle zone here. So between those two x values, from negative 4 to 5, I'm positive. And then I'm negative or 0 outside of those, from negative infinity to negative 4. And again, we can use a bracket there, union 5 to infinity. 35. Okay, let's see. All right, so here I'm positive. This is a x-intercept, is what that is, and that's another x-intercept. Again, since this is a quadratic function, we are negative over here. So we also can say that over here we're negative. So with that in mind, we would say for the positive part, between negative 6 and negative 2 is where I'm positive. For the negative part on part B, we would say negative infinity to negative 6 with a bracket, union negative 2 to infinity. All right, next one again here. I'm positive. I'm x-intercept here. I'm negative. And then I am on x-intercept here. Okay, so for part A, I am positive from negative infinity to negative 2. Now, we'd also be able to say from the other side of this x-intercept to the right there, it's going to be positive as well. Since there's already a negative zone here in the middle here between the x-intercepts, that means there's two positive things on the outside. So union would be 4 to infinity. Part B, we would say between -2 and 4 is when I'm negative. All right, and let's see, a couple more here. Same stuff here. Now we can do some of these a little bit different. And this one maybe we can treat them the same way. Might be easier as we look at this as two sides of a graph, and we're going to use a graphing calculator on this one. I'm going to put in this left side in for y1 and this in for y2 on the right side. So let me split my screen here. And let's go ahead and get the TI calculator up here. All right, and let's go into the graphing feature and let's put 6x squared minus x. And then for y2, we're going to put in the number 1. And the way this is phrased here for 55, we're saying here, when is the 6x squared minus x graph below 1? Okay, so let's hit graph. All right, so we can see over here. I can't point on the screen, but I can try to mimic it. We see that we have a parabola, and it does something a little bit like this. And then we see here is the red line. That's where y is 1. And we see that we're in between these two areas. Right here is when I'm below 1. So I got to figure out what are these x values of this location and that location to tell me that, hey, between those two x values, I'm below 1. So let's go up to the table feature, second graph, to get in the table. And I want to look at what I have here and figure out when, and this is the challenge, is my scale is going by ones here. On the x here. So we see at -1, I'm at 7. At 0, I'm 0. At 1, I'm at 5. So really somewhere between -1 and +1 as x values is when we are below y is 1. Because at the first one there, at -1, 7, I'm above. And then at 1, 5, I'm above. So we would say here that between -1 and 1, I happen to be below that line. Now, if we wanted to get more exact, we can change and figure out. Okay, let me go back to the graph. We're going to press second trace, and we're going to do option number 5, the intersect button. And now this is where I want to say, okay, what's my first curve? I'm going to arrow my thing to the little bit above the red line and press enter. Then arrow it down below. Let's see, is that down below? Here we go. That's going down below. All right, that's below. And I hit enter, and I tell it to guess. All right, my calculator's not cooperating here. All right, there we go. So this is telling me that at x, so on the right side here, when x is equal to 1/2, the y value is 1. So that tells me 1/2 is the right bound side. And then let's go over to the other one. I'm just going to use a trace feature. And let's see. Let's try to intersect that better. Challenge this one's really tough because it's there we go. First curve, second curve, and guess it, and that's going to tell me -1/3. All right, so that's where it is there. Now so that'd be the more precise answer, is what that is. Just trying to get an eyeball there. We could treat 57 like we did ones up above. We could graph it. They tell us here these are our x-intercepts. I have an x-intercept at -4 and at x is equal to +10. And so when is the graph below or equal to 0? Well, this quadratic function, if we multiplied it out, would be x squared minus 6x minus 40 less than or equal to 0. So this parabola opens up. We know it's at -4 and it's at +10. So and those are my x-intercepts. So that tells me between -4 and 10, I am less than or equal to 0. So between -4 and 10, I'm there. So again, several different ways you can do it. I think like the 58, it's easier to say, okay, here are my x-intercepts. X equals 3.1, x equals -2.7. And when am I above? This parabola again opens up because x times x is x squared. So when am I open or positive is what that's saying. Well, that would be from -infinity to -2.7 union and then 3.1 to infinity is what that would be. Again, you can graph it and see, and you take a look at the graph, you'll notice that at those x values that I have listed here, that to the right and to the left of those respectively, then that's what would happen. All right, so we'll do another video for the word problems here.